Welcome to the Fire Break. I'm Steve Wolf. As you know, the Fire Break is sponsored by Team Wildfire, developing some new jet engine powered technologies for pushing back wildfires. Pretty excited about that. But that's just one small piece of the pie here. It's going to take a lot of different approaches to handle the wildfire problem as it emerges and as it grows and as we learn more about it. And one of the really interesting technologies that people are watching that I'm certainly excited about following is a company called BurnBot, which I would describe as the Zamboni of the forest. Right? It's a machine that travels through the forest and burns vegetation and then leaves it in hopefully a safe state where it's no longer flammable. So I've got Dr. Lee Haddad with us today. Lee is the co-founder of BurnBot, a physicist, engineer, and I'm going to say bon vivant, just because I like the word. Lee, welcome to the Fire Break. How are you today?
Steve, I'm doing well. How are you?
I'm good. Energized. I'm excited to meet you and chat with you.
Likewise.
So tell me a little bit about your background and how that led to BurnBot.
Well, my background is diverse, really. I mean, I'm a physicist, and I started out working in laser physics, and then sort of changed fields a bunch of times. So I did a lot of stuff with imaging systems, lasers, optics. I worked at Lawrence Livermore for 8 years as my first postdoc, and I did a lot of things there with X-ray imaging. Micro holography was my PhD thesis, and so most of my background's in imaging systems, but then I started working on medical devices, biometrics, and other kinds of security systems. So I've bounced around quite a bit, and I like doing that. I like learning something in one field and then kind of transferring that knowledge and ideas into something new.
Yeah, that gives you the perspectives that allow you to make connections that people who've been exclusively in one field can't see.
That's right. Yeah, and there's always connections. There's always ways to use either ideas or even technological components from things in the past with new things, and that's certainly the case. I think with BurnBot, I'd never worked on a fire related technology or business, but it was very interesting for me to learn about fire and how things are done, typically done, and try to come up with ideas of ways to do something a little different, maybe better.
Yeah. So how's that going? And how are you enjoying playing in the fire space? Because the fire space is, it's really a new space, right? Because you can go into that space now and meet lots of other really interesting people who are also not elevated from inside the wildfire space, right? It's like full of what they probably feel are strangers, but coming in with a lot of new ideas. How are you liking it?
Yeah, that's true what you said, and I like it a lot. I like a lot of things about it. It's very interesting. It's fun to burn things.
Yeah.
I've played with fire since I was a kid, like probably most of us have, and so that's fun. But also, everybody in this field seems to be really passionate about it and motivated to try to make a difference. And I really feel like everything that everybody's doing in this, larger field of fire technology, or just not even just technology, anybody that's working in the business of trying to help with the wildfire problem is doing something valuable and that's needed. So it doesn't feel like, there's competing companies. It feels like we're all working together as a big team to try to make a difference in this.
Yeah, not only not competing, but like there's not enough of us.
There there aren't enough. So that's actually one of the things that we're really trying to do with BurnBot, is to help scaling. So what BurnBot does is the BurnBot machine basically puts in black lines, and it does it using, we like to sort of say simulated prescribed burning, or we do it with technology instead of with the typical way that's done now with drip torches.
Right.
Because we do it that way, the machine contains the fire and produces much less smoke, prevents embers from going anywhere. And so we're actually able to put in black lines with a much smaller crew. And putting in the fire breaks and black lines is the most labor intensive, difficult, and risky part of doing prescribed burning. So by doing it with the machine, we can use a very small crew of people where you would normally, in the typical fashion, you would need maybe 40, 50 people to do the job with a lot of advanced planning. And with the BurnBot, we can operate in a wider range of weather conditions. We can operate in areas where you wouldn't normally do it because the risk is higher. We can operate over a wider seasonal range because we can actually burn wet grass with the BurnBot, and we can also burn in very, very dry, high fire risk times because we're able to contain everything and prevent any slop over.
Are you seeing that not only does the capability of the machine allow for less people, but within BurnBot itself, less and less people required to operate the machine? Because I would imagine when you go out with something that is at near prototype space, one person gets to play with the remote control and move it around, and then the other 12 people keep it running. And then the next iteration, it takes only 9 people to keep it running. And then eventually just the operator can go out by themselves.
Yeah, we're down to like 6 people. So, and we probably don't even need that many people, but we just want to make sure that everything's very safe. So only 1 or 2 people can actually operate the machine, but then we have other people there as spotters that can help refill the resources the machine needs, like water and propane and things like that.
I see.
So we can operate the machine with a small crew, which is part of how the scaling works. That way, the same number of firefighters, that same 40 or 50 people that you would normally need, can do 10 times as much with the BurnBot.
Right. And now that there's 25% less of them, the need for more powerful technology is even greater.
Well, that's another problem that has to be solved somehow too. I mean, those guys that go out there and do that work, they risk their lives and put themselves in very difficult and stressful situations. And I don't think we appreciate them quite as much as they deserve.
Yeah, well, they're certainly underpaid, and then the idea that they're applied seasonally, when there's more fire and when the bell curve is higher, versus having employment year round, you're either fighting a fire or doing fire mitigation, would make a much better career opportunity for them.
And we're hoping that BurnBot will help with that, because we'll need, as we are able to build more machines, we'll need people to man them and help maintain them and operate them. And as I said, we can actually run the machine over a wider seasonal range too, so that they can even go out in the field and do put in fire breaks even before a fire season comes around.
And technically, right now, what are the speeds and feeds on the machine?
It varies. I get asked that question a lot. It varies very widely based on the vegetation, the type of vegetation, the density of the vegetation, and how much moisture is there. So, as you know, like different kinds of vegetation, some stuff burns hotter than other stuff. And
Right.
So it varies quite a bit. The speed ranges that we've seen so far with the machine vary from about, for it to travel forward at a speed of about between 0.1 meters per second up to about 0.5 meters per second. That's
Okay.
what we've operated sort of in that range so far.
Okay, successfully. And what do the trip ups been? What foils the machine?
Oh, I mean, there's certain kinds of terrain we can't operate on. If there's a lot of large physical obstacles, like a bunch of dead and down trees or something like that. If there's too much woody understory or whatever you call it, like thatch layer, if there's just too much material, it depends on things like that. the new machine we have, we've operated it so far on hills as steep as 30-degree angle. So that's pretty good. But at some point, the steepness of the hill will affect the operation as well.
Okay.
We
And
still have some testing to do.
always.
Sorry, go ahead.
I don't imagine there'll be a time when you don't have more testing to do. I mean, these technologies are so new; they have many, many iterations to go before anyone says it's done. And by the time you say it's done, the conditions on the ground will have changed again, and you'll need a new iteration. So
We're already working on a new design for just to expand the capabilities of the machine and where it can operate efficiently. So I'm working on a new design for that.
well, that's exciting. And so, what's the division of your time? How much time are you in the lab versus, hitting up investors and the other things that we do as co-founders?
Fortunately, my co-founder is awesome, Anakul, and so we roughly divide up the business in this way that he sort of runs the business side and I run the technical side, technology side. But we have crossover, so I do spend some of my time meeting with investors, going to meetings with Cal Fire or anyone else. People from, for example, customers like PG&E. So I do some of those meetings. But fortunately, a lot of that gets done by Anukul, so I can spend more time in the lab and managing the technical team. I don't know what the breakdown is. It's probably like 70-30 or something like that. Where I'm in the lab and managing the team directly 70% of the time, I'd say at least.
And for some of us, we find things are easier than people.
Well, in my job, I have to deal with both.
Yeah, no, of course.
But Anukul and I basically run the company, so we're the board members and the company executives, so officers of the company. So that's how we run it.
And how many pieces of hardware do you have in the field now?
Well, we have the old machines, the very, very early machines we don't run anymore, what I call the mini BurnBot. But we have two machines right now. One is what we call the RX1. That was our previous iteration of the larger machine. And then there's one RX2. We're building the second RX2. So the RX2 is our newest machine, which is really our production model.
Okay. And is that fairly well dialed in for mass production now? And when I say mass production, what does that mean to you? What do you see as the ideal fleet size for your company?
Well, so the difference between the RX1 and the RX2, I focused on four things. One of them was manufacturability. The others were reliability, usability, and serviceability, field serviceability. So we've put a lot of design effort into those things, which is why the RX2 is our production model that will be able to go to production. There's still some tweaks we're making on it, because we're just doing early field testing right now, and we're going to find those little things. But most of the things that we need to fix on it are little things. I think the basic design of the machine is pretty well dialed.
Once you're down to the little things, that's only 90% of the problem left, right?
Well, it could be that way. I hope it's not quite like that, but I think we're pretty close to going to manufacturing more of these machines. And I just hired a director of manufacturing operations too. So.
Oh, wonderful.
Yeah.
So how do you see, the fleet growing? Where do you think you'll be, at scale?
Well, I mean, we have to see how it's going to go. I think we'll have two machines this year, by the end of this year. And then next year, I would like to build at least three more machines next year. In order for us to have a really big impact, we have to scale quite a bit. So we need at some point to get to having tens or even 100
Hundreds.
machines,
Yeah.
or maybe hundreds eventually. But they're big machines, and they're expensive.
Yeah. Well, it's a big planet too, and it's burning. What's the propane consumption on that
Oh,
on average?
yeah, that's a great question. Again, that depends dramatically on the vegetation and the conditions.
Right.
So, if the vegetation is pretty moist and pretty dense, we'll burn one. We'll burn. We use forklift tanks, so we
Okay.
actually flow liquid propane.
LPG.
So those are 33 pounds of propane. Each tank holds 33 pounds of propane. So if the vegetation is really wet and dense, we'll burn, I think it's about half an hour, one tank in half an hour, 33 pounds in half an hour.
Okay.
However, on the opposite end of the spectrum, if the vegetation is dry enough and under the right conditions, which is pretty often, we can actually burn with no propane. Once we ignite
Yeah.
the fire inside the chamber, the way the machine works with the fans on top drawing
Hmm.
air out of the chamber, we create kind of a firestorm inside the chamber. So the fuel on the ground, the vegetation fuel on the ground, will generate enough energy to just keep the fire rolling with the machine.
It's like when you're welding. At some point, you can shut off the acetylene and just go off the oxygen, right? Because
You get so much heat from the
yeah.
It's kind of cool because we've already in field testing in the past, we've burned thousands of feet of blackline with no propane torches off.
Nice.
Or
Yeah.
you can just we have 3 rows of torches, so we can actually just turn on only the first row of torches just to light
Okay.
the fire
Right.
and use much less propane.
And have you played with it? Can the machine run on hydrogen?
So yeah, that's a good question. I got really interested in using more sustainable fuels, like methane was one I was really interested in because you can recover that from farms
Right.
and other sources. And methane is a strong greenhouse gas. So by burning it, we would convert it into basically CO2. We'd be producing CO2 in water. And CO2 is about 25 times less impact on the
At least.
as a greenhouse gas. But methane, the phase diagram for methane is not practical. We can only store it as a high pressure gas. So
Right.
we can't store enough methane for the amount of weight for the tanks and all
Yeah.
that.
Right.
Hydrogen has a similar problem, and it's also, it's a very dangerous gas to work with. It's much more prone to leaking, of course, than propane. It's just, and it's harder to store in quantity.
Well,
You can't see the flame. You can't see the hydrogen flame very well either.
right. No, you can't. You can see the black line though. Yeah. One of the pluses of working with hydrogen though is when if you get a propane spill, propane is, heavier than air and it'll go down and pool and surprise you. If
Yes,
you're burning hydrogen and you get a leak, it's up to the outer atmosphere before you know it.
that is true.
Uh,
That is true. We don't have so much of a problem with pooling unless we're doing some lab testing because we have the fans drawing the air out of the chamber. So we don't really get that pooling, at least not in the field.
okay. So what are the next big tech challenges? You said like one of them is scaling. One of them is going from prototype phase to, a manufacturable, repeatable item. What are some of the little things that keep you up at night?
Well, we've had a bunch of those in the past. We've ended up having to use some special materials in certain places because we get crazy high temperatures in the chamber. We've seen basically 1,000 degrees centigrade inside the chamber.
Yeah.
I had no idea when I started on this project. I had no idea it was going to get that hot in there. So we've had to solve a lot of actually quite interesting technical problems related to that high temperature. I think we've solved most of those. So as you said, there scaling is one of the big ones we need to do. We also like to be able to make the machine go faster.
Sure.
And so that's tricky because you really want to be able to consume all the fuel inside the chamber before it passes.
Right.
And so that becomes tricky in terms of the consumption of the fuel inside the chamber and also making sure that extinguishment is done very effectively on the back. And it's harder to do that when you go faster. What we have now, even at half a meter per second, again, depending on the vegetation, is quite can be quite effective.
Yeah.
But some stuff, takes longer to burn than other stuff.
Sure. Well, just the way, electric cars now, are using regenerative braking, right, to recover the energy from the braking. Are there opportunities for you to use, regenerative uses of the heat? I would think if you had a boiler in there with water in it, you could generate steam, and the steam could operate the fans.
Yeah, steam turbines. Yeah,
Yeah.
yeah. I went through this exercise, thinking through all these things very early on. How can we get some of that heat energy and use it for something? And I thought about thermoelectric devices. I thought about steam turbines. I thought about all kinds of things, but they end up not being very practical. There is one very practical thing that we do, though, because the way our torches work, we flow liquid propane. And then we vaporize that propane in small quantities as needed by the torches
Okay.
using these propane vaporizers. They're little devices that have convolutions inside. They flow the propane next to the little channel that has hot water flowing through there. So the hot water, takes care of that, balances the energy that's absorbed by the propane expanding.
Okay.
So we need hot water. So we actually recover heat energy from inside the chamber. So, and we kind of try to solve two things at once whenever we can. So as I mentioned, we have very high temperatures in the chamber. So what we do is we have an air blower that blows cool air in through the frame, the lower part of the frame.
Okay.
Cools where the axles are. And then that cool air then goes into some tubing that runs along vertically on the inside of the chamber. And those tubes, it's like a heat exchanger. They absorb that heat energy from the chamber. Then that hot air then goes into a second heat exchanger that warms water. And we use that warm water to heat the propane vaporizers. So that way we don't heat water directly because we don't want to get high pressure steam in case the temperature goes too high.
Yeah. Tell me about some of the trial clients. I spoke with Amy Berry at the Tahoe Fund.
Oh, you did?
She had just had you guys come out and, I would say, more than demo for her, right? You did several acres there.
Yeah, so that was the first visit with the Tahoe Fund. The first event with the Tahoe Fund was done with the other part of our business, which is where we do mechanical thinning.
Okay.
So we had a bunch of masticators out there that cleared a bunch of vegetation. I forget how many acres. I think it was like 20 acres or something like that.
Yeah.
Mechanically. But we're planning, I think in October, another event with the Tahoe Fund where we're going to bring the BurnBot and do burning.
Okay. And so once you've done mastication in an area, is it more efficient to then run the BurnBot over that area, or harvest the masticated fibers and then just burn them centrally?
Well, I have a plan to do this harvesting thing that you mentioned. That's another project actually.
Okay.
That's actually on my roadmap, my technology roadmap. As far as mastication is concerned, it's a little bit of a double-edged sword. So there are places where there's very heavy brush or thick, I don't know what you call them, small trees or small bushes, and it's just too heavy for the BurnBot to go over by itself. So those things would have to be masticated first. However, just in general, we've actually looked at going over masticated and mowed grasses, and it's not too surprising really that it's mostly it's worse when you do it over masticated or mowed grass, because when the grass lays down, it's harder to get the oxygen and the fire in there.
Yeah.
It's actually better when the vegetation is standing up, because it just gets oxygen in there much more easily. So I'm actually planning to put some devices in the BurnBot to help raise that material up,
Right.
like a rake type system.
Yeah, like some Roomba rolling brushes.
Yeah, something like that. Although it has to be something very simple if it's inside the chamber, because again, 1,000
heat. Yeah.
degrees, you know.
Right. So you're looking at titanium hair rollers, basically. Right.
Well, we try to stay away from materials like that because they're just too expensive. So we try to figure out ways to do it with more economic materials. You know.
Okay. So if we talk about the economics, then where do you feel like the value makes sense for clients? Like how much will they pay, per yard of black line, I guess, is one of the questions. And it depends what's on either side of the line.
I think we're still trying to figure that out. But one of the things that we know about the BurnBot is it has a lot greater value than just the initial black lining. Because first of all, those black lines last quite a long time. So depending on how we burn it, we've done burns where the black lines are still there a year later, or even a year and a half later. Not really completely a black line. There's some regrowth, of course, but it still serves well enough as a fire break.
Because you're kind of kiln drying the soil there. You're sterilizing it and baking it, not just, trimming the top off with some fire.
Well, I don't think we really get to what I've just learned a little bit about this. And I'd heard this term sterilizing the soil, and I didn't really know what that meant. So I'm still kind of learning to understand exactly what that means. But I really don't think we actually sterilize the soil, because we pass over pretty quickly. So I don't think we're getting to that level of heat exposure. But what we're finding is that we have a lot of knobs we can turn to adjust the way the burn is, the temperature of the burn, the dwell time, and a few other things. And we're finding that it's looking like the BurnBot will be able to burn things in such a way that knock down invasive grass species and allow the native grasses to come back.
Oh, interesting.
And those native grasses actually hold moisture better than the invasive species. So, in fact, we're starting to do some experiments in collaboration with Stanford and with people from the Cleveland National Forest to understand how to make the BurnBot more efficient in doing exactly this, to kill or suppress, mitigate in some way the invasive grasses in a way that allows the native species to come back in strength. And that is something that has a lot of value, because now it's not just a black line that's temporary. It's something that is really going to minimize fire risk, ignition risk in particular, for a longer period of time. So then the value of operating with the BurnBot becomes much higher than just a one-time black line.
Right. So could you modify it so you could drive it through a row of invasive grasses, and then and at the back of the machine, when, passing over the burned area, then it applies the fertilizer, and it drops the seeds for the native grasses.
Yeah, we've had both internal discussions about this, and we've heard this suggestion from
I'm sure you've heard it all.
Other people too. It's a cool idea. We can replant afterwards.
Yeah, why not?
I mean, there's no reason we can't do that. it's it just, you'd have to carry those resources on the machine, but there's really no reason we can't do that.
Right. Well, you got 6 guys standing around. They should do something.
Yeah, or even have a separate machine that
Yeah.
goes and
Right.
like
Just
that,
come
right?
in behind machine.
Yeah.
Right. Yeah.
We do have to make absolutely sure that once we do some burning, we make absolutely sure that there's nothing left to, start a fire later.
Right. Have you had any escapes?
No,
Okay.
no,
So far so good.
we haven't had anything like that that we know of.
Well, you would know.
Yeah, we haven't heard of anything like that.
The server would be knocking on your door, right?
Yep.
Yeah.
Yeah, no, we're watching for escapes, or what I guess the proper fire term is slop over. So we're always watching for escapes at the sides and at the back of the machine.
Yeah.
And we will have emergency sprayers on the side as well that automatically turn on in case there's a side escape. But the machine can drive right next to, you can actually see it in some of our videos where you'll see the side of the machine. You can actually kind of see the flames inside
Yeah.
through the skirt. And then there's grass, dry grass rubbing right against the machine. We occasionally, when we're operating in the field, if we make a very tight turn or something, there can be a small little slop over there, and then
Right.
that's put out right away immediately.
So is that using your sensors background?
Yeah, the emergency side sprayers is using my imaging technology, my background in imaging systems and sensors. Yeah.
That's great.
Yeah.
Yeah. Interesting. So we're going to paint some black line. And I imagine that nobody says, okay, BurnBot, that's the solution, or this technology, that's the solution, right? It's more, it's more tools in the arsenal.
That's exactly.
Right? And so if someone's job is, asset protection, then what does the suite of tools look like, of which BurnBot is a part?
Yeah. So, well, even BurnBot, our company has a suite of tools. So as I mentioned, we have the masticators, we have the mechanical thinning, and we have a whole section of the company that does this. And we have quite a lot of machinery to be able to do this. We have remote controlled masticators, relatively small ones. We have larger remote controlled ones. We have masticators with a person inside the machine and excavators. So we have a whole team that can do that side of things. Then we have the BurnBot, which we call the RX program, the machines that do this burning. And we also have a drone that can light fires, can drop these little fireballs.
Dragon eggs, right?
Yeah. I like that term, actually. I think that's, so those things actually can all work together. So you can have a situation where there's an area that has very light fuels and some heavier fuels. So we go and masticate the heavier fuels down. We come in with the BurnBot and burn black line around that. And then we also segment the larger area. So we'll burn a perimeter and then burn some lines inside that perimeter so that you have smaller units of unburned vegetation.
Okay.
And then you can come back later and burn those individual units, either using the drone or using drip torches or whatever method you like. And you don't have to burn those smaller units. You don't have to burn them all at once. So that reduces the smoke load on any community or infrastructure nearby. And so they all work together.
And when we talk about, prescribed fire, people get what that means. But there's now this concept of prescribed smoke, and right in that we're going to turn the nearby vegetation into smoke a little bit at a time instead of all at once.
I haven't heard that term, prescribed smoke. That's a good one.
It's not what happens at 5:30, right? Right.
Right.
Yeah, but so the idea is prescribed fire really is only of benefit to a community directly if it creates a buffer between that community and wildland.
That's right.
Right? You're creating this pre-burned perimeter. And very often that's not how you see prescribed fire, because they don't want prescribed fire near their community because they don't want the risk, or they don't want the smoke. Uh,
And they don't
the
the smoke.
the flip side of that is that when you do get in a fire, even as we're seeing now, even hundreds of miles away, you're going to get a lot of smoke drift. And so if you know
Yeah.
what the flight lines of the smoke are, then you can go out and pre-burn for that as well, just as a form of prescribed smoke.
Yeah, exactly. With the BurnBot itself makes very little smoke because we burn at high temperature and high oxygen.
Yep.
And we also suppress the smoke in other ways. There's some equipment in the fans that helps suppress the smoke and embers. So what we can do is what I call raster burning. We can, the BurnBot has a 1.5 meter wide strip, but we
Okay.
can go back and forth and then, put in a relatively large defensible space. Let's say you're near a hospital or a community.
Right.
You can put in a pretty good defensible space, 50 feet, 100 feet, or whatever is needed with the BurnBot with very little smoke. And then you, again, put this perimeter around the rest of the area and do what I said, segment that large area with more black lines. And then come back and burn those units individually. And that way, the community doesn't really feel it that you're doing this operation. They just don't. They don't get the smoke. It's not even very noisy. It's not. It's not. It doesn't have this dramatic effect of an open burn where you see this big
Right.
fire and all this smoke. But they get the protection, and then the rest of the area can be burned out little by little. Again, minimizing the smoke load. And that's another way of scaling because we don't have to burn the entire area using the BurnBot.
I see. So you could do as wide a strip as you want with repetitive passes, overlapping passes.
Okay.
Have you done any experimenting with zebra striping an area where you just pass grass, pass grass, pass grass, and then as a fire came through there, it would only have half the fuel to work with?
Yeah, we're doing those kind of experiments now. We're also, again, as another way of speeding things up, we're experimenting with putting in black lines with a gap between them
Mm-hmm.
and then burning that gap using drip torches or some other method.
I see. Okay. So that way you don't have to
We can,
run all that propane for every blade of grass that you're trying to get rid of. You're
yeah, exactly.
basically laying in a perimeter around an area that you're then going to apply prescribed burn in a conventional manner to, and minimize the
Yeah,
chance
that's right.
of an escape that way.
So yeah, we're looking at all these different ways of burning larger areas faster. Anything we can do to scale the use of prescribed fire. We
And
try
what
to
about
find.
as an alternative, using the masticating / harvesting model to basically collect cellulose and then create a market for that, low grade cellulose, which, toilet paper, paper towels, things like that don't need, dimensional board lumber. Because I remember they used to say, don't use the paper towel, you're killing a tree. Right? Well, they're not using trees to make paper towels. And I think if there's an economic market for this lower quality cellulose scrub plant stuff, then that creates more economic incentive for the masticating, harvesting, processing model.
Yeah, I actually submitted a proposal to the U.S. Forest Service for a machine to collect this material after mastication
Yeah,
and process. That proposal did not get funded, but we're going to be looking at that anyway. It's one of the things on my roadmap. And there's several markets for this, not just things like paper towels. There's also people that have bioreactors that can use that material to generate energy
right.
in a
Pelletized
kind of a sustainable way.
wood things.
Yeah.
Right.
Yep,
And then I guess
exactly.
if you harvest the pelletized wood and then you burn them in an energy producing facility that runs off the same concept as the BurnBot of, very high temperature, high oxygen usage, then you get a much cleaner burn than, people are just burning wood logs.
Yeah, that's right.
Much more efficient. So what do and this is now pure conjecture way off into the realm of science fiction. But what do you think are the factors that would have them fund or not fund a project like that? Is it witchcraft, or they don't see your vision, or like, because I mean, there's a lot of people. Well, not a lot of people. There are people like you with great visions for, there's a better way to do this. We can get a handle on this. We can take this problem fuel and turn it into a beneficial product, or into energy. And then there's someone up there going, yes, no, 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 yes, which feels kind of arbitrary because you're presenting solutions that really have value. How do how
Yeah,
do you get to influence that? How do you get to be the guy deciding what gets funded and what doesn't?
that's a great question. I personally think this is a problem in the United States. We have a problem with this. Um, I've been doing this for a very long time. I've been in this technology science business for a long time, and I've written many proposals. And what I've found is it's very, very difficult to get funding for almost anything. It's too much work. It's too hard. There's too many hoops to jump through. Somebody said like the reward is not worth the number of hoops or something like that. Uh, it's just
Right.
it's
The juice
we're
isn't
we're
worth the squeeze, right? Yeah.
pretty much, I mean, of course, people do get funded and for doing great things, but the selection process is just way too onerous. And as you said, I wouldn't say it's random, but it's a lot of it has to do with things that are not based on merit, the merit of the proposal.
Okay.
I don't know if we put enough money into science and technology research and development. I don't know if we're doing that enough in this country. I've seen hundreds of millions of dollars go into funding things that never would have worked, and where that money all got wasted, went down the drain somehow. It's very frustrating to see that when you see a company getting funded $400 million that goes all down the drain, and you
Yeah.
think you could have funded 100 companies at $4 million, 100 startup companies that could have
Right.
something. Uh, it's very frustrating. I don't know what to do about that problem. I think it's largely a political problem. So I'm not sure what the solution to that is. Um, but I mean, that's certainly something. If I had billions of dollars, I would be funding companies to do things, but I don't have that. So I
When you
just
have, right?
I just try to do what I can.
Yeah.
But,
Well, I think you're right. Making small bets on more companies is a better way to go. But that's not our decision either, right?
and making it easier, some of these proposals, these processes through the National Institutes of Health, or through the military funding channels, like any of these things, National Science Foundation, NIH, any of these things, it's so difficult to get funding through them. It's so much work, and there's so many people applying for it, and then the grants are relatively small. And um, for example, I submitted a proposal once. I was actually asked, I was invited to submit a proposal for a medical device, and there were 150 proposals that went in for that.
Wow.
Into that, there was a pot of money that had been earmarked by Congress. And before the grants went out, a pork barrel deal happened in Congress where one of the senators just took all that funding to pay for building a factory or something in his state. So 150 scientists had submitted this proposal and nobody got any money because of a pork barrel deal in Congress.
No,
Yeah,
it's
right.
not in America.
Yeah, hard to believe. Huh?
I can't believe that. Yeah, no, I agree. So what happens? So I would imagine you have a similar experience to what I do when, uh, Congress announces, $2 billion for wildland firefighting, blah, blah, whatever, and then everyone emails me, hey, look at this great news, and that money's already been allocated or it's already going to departments that are just going to do more of the same.
Exactly.
It really doesn't leave a lot of the money towards innovation.
Yeah, there's a lot of that. There's a lot of fear of change.
Mm-hmm.
I also saw this when I was working in medical device development, the same thing. You come up with some new technology and people are like, well, that's not the way we do things. And it's a similar thing, I think. Fear exists for a good reason too. It's just how you handle it. So, when you're dealing with things that are life and death situations like medicine or wildfires, I can understand why there's some reluctance in changing the way things are done. But we don't want to let that, suppress the development of new things that are going to really help and make a difference. So it has to be balanced properly. Yes, you want to be careful, but you also want to move forward.
Right. I mean, you kind of have to take the doctor. I forgot his name. How's that working for you, guy?
Uh,
What's his name? Doctor. Oh my
this-
gosh. Well, someone will type it in the chat, I hope. But um, but what we know is like what we're doing is not working, and it's not working by a greater factor every year. Like if
exactly. So something has to change, and somebody has to step up and say, okay, we're going to move things forward. We're going to provide funding. We're going to do some experiments. We're going to devote some resources, not just money, but time and human resources and energy, pay some attention to it. We've seen that changing a little bit, I think. When I first started this company with Anacool in it wasn't even a company in 2020. It was just the two of us working together. Prescribed burning, that term was something you didn't really hear much. It wasn't like in the news. It wasn't something that most people were talking about. And then in those few years since then, it's become a pretty prominent topic. Whenever people talk about wildfires, you hear about prescribed burning.
Yeah,
And
right.
people are starting to
And
be
there's
more
still
open.
people saying like never ever, and there's a lot of people saying we're not going to survive without it.
Exactly. Yeah, it's much more openness to having prescribed fire.
Yeah, and there has to be some risk tolerance for that, and there has to be some risk mitigation around that. Because when you get a prescribed fire go rogue, like in New Mexico,
Oh, yeah,
then all of a sudden people are like, oh no, never allow this again. Well, of course, that's just going to contribute to more fuel buildups on the ground.
exactly.
And so they have to somehow mitigate that with either laying in black lines around the prescribed area or chemical retardants applied as a chemo barrier as well. But we have to have a way of making prescribed burns safer so that we can improve their reputation and therefore increase their acceptability to the communities.
Exactly. Yeah, and that's what we believe BurnBot can do. That is make prescribed fire very safe, very efficient, um, and scalable.
Wow.
That's what we're trying to do.
Fingers crossed all around, right?
Well, that's our goal.
Awesome. Well, you're making great progress on it, and I think that we'll probably see more and more opportunities for easier financing in this as people recognize the potentials in wildfire mitigation and suppression.
Yeah, I
The
do hope
problem's
so.
getting worse, and the people who are suffering from that problem are desperate.
Absolutely. And I do hope that BurnBot will be able to get more resources and put more horsepower behind this. But I hope that for everybody that's working in this field, not just BurnBot, because like I said, everything that everybody's doing is needed and should be very well supported.
Yeah. Well, I think the support may come more from the venture capital community and private equity because they see an opportunity there. And then as a founder, it's just so much more efficient. You put one data room together, it's a sufficient application for anybody. You have a 10-minute talk and you have a yes or a no. And you're not spending, months and months developing individualized SBIR proposals.
Yeah, those are terrible.
Yeah, that system should be revamped too. Is there a BurnBot for that?
Uh, so, yeah, that's kind of what I was talking about with this proposal process. That's just terrible. I mean, it's a little more than a 10-minute conversation with investor for sure. It took us a lot longer than that, but
Well, you can get a no pretty quickly, at least.
well, that's true. It is a lot quicker and more efficient than all this proposal writing, and the checks are bigger too, or can be.
Right, and there's less reporting requirements and grant compliance and all that.
Yes.
Compliance comes on the balance sheet,
Yes, exactly.
which you're doing anyway. Yeah.
But I will also say, I mean, BurnBot is VC funded.
Yeah.
But I will also say that not only on the technology side, but on the venture capital side, the investors that we have are excellent. I'm very impressed with those VCs. This is, I think, my that sort of 12th startup company I've been involved in, and I was a founder in several of those. So I've had interactions with VCs before, and they're definitely not all the same, and they're not all good. The people that we're working with at BurnBot that have invested in BurnBot are amazing venture capitalists. I'm very impressed with them. They are passionate about this field, and that's an important thing for me in accepting an investor into our business. They have to be someone who really cares about the mission.
Yeah. And not as a brand name, but just as a generic term, double bottom line. And I'm not just talking about Nancy's fund, but the idea that, you want people on board, yes, they see a financial upside, but more importantly, they see an ability to protect lives and property and homes and make a difference. So.
They're not just doing it for the money.
Right. They might not be doing it without the money, but it's not their only motive. And in some cases, the money is really not the motive at all.
Everybody needs to get paid. Everybody wants to make a profit, but
Sure.
it can't be the only thing in this business, at least for me. There has to be a focus on the mission.
Well, Lee, I look forward to touching base with you more often as you make progress, and please do reach out to me so that we can update Firebreak audience. As there's new things to tell from the BurnBot headquarters. So
Thank you, Steve.
Yeah, thanks so much for joining me today.
Thank you very much. I'm excited about what you're doing as well, and I'd like to hear more of that. So let's stay in touch.
I certainly will. Folks, this is Lee Haddad, Dr. Lee Haddad, multi-founder, lead technologist behind the BurnBot technology, for which I know he gives a talented crew a lot of credit. But also, credit where it's due at the top there. Lee Haddad from BurnBot. I'm Steve Wolf. You've been listening or hopefully watching The Firebreak. The Firebreak is sponsored by Team Wildfire. Be careful out there, and we'll see you at the next one.
Thank you so much.